Ready.
Okay, let us try to understand the circuit diagram. You see, our objective is to measure power in RLC circuit. So for that I took a resistive load, inductive load and capacitive load, and I have connected everything in series. We know the meaning of series, right? We should connect element one after another. So you see, all are variable loads: variable resistive load, variable inductive load and variable capacitive load. Now what is the objective? We want to measure the power, and we know that in AC circuit the power is nothing but VI cos phi. Am I right? So now if you want to measure the power, I need to measure the voltage, current, and also I need to measure the power factor. So instead of using three different components to find out the total power, I am going to use the meter called wattmeter. This is what actually wattmeter, which will helps to measure voltage, current and power factor simultaneously, and it will give final real power output from the circuit. Okay, for that purpose only we are using this wattmeter. You see, in wattmeter there are four common terminals: M, L, V and C. Where M is nothing but a main, L is a line terminal, V is a voltage terminal and C is a common terminal. And as I said, wattmeter helps to measure voltage and current, right? And we know if we want to measure the current in the circuit, we use generally ammeter, right? And see, you can see that with this load, one of the winding in wattmeter is connected in series. So this is actually going to measure the current, and this we call the term current coil. This is what current coil, which is connected in series with the load in the wattmeter. And then I said, no, it also going to measure voltage. So for measuring voltage, we know that we generally use voltmeter, and that should be connected in parallel. You see, this is what the parallel connection. You see, this is connected parallel to the load. So this coil will measure the voltage, and it is referred as voltage coil. So generally in wattmeter there are two coils, current coil and voltage coil. The current coil measure current, which has to be connected in series with the load. Voltage coil measure the voltage, which needs to be connected in parallel with the load. Okay, so this will measure the total power. And then with this setup, I also connected ammeter in series to know how much current the load is taking. And you know that ammeter always needs to be connected in series. So we are connecting this in series with the load. So this meter can also be kept here. So the objective is this ammeter must be connected in series with the load, right? And also I want to see how much voltage I am applying to my load. So for that I am using this voltmeter, and we know voltmeter must be always connected parallel to the load, right? This is what the load point. So across this I am measuring, that is I am putting a voltmeter. Okay, and remember this can also be kept over here, right? You need to connect across the load, right? And then after this you can see one is a new component, which is auto transformer. And after that you can see I am giving single phase AC supply. Okay, and now you may ask, sir, why we need to give this auto transformer? Why can't we give directly the 230 volt to my load? Why we are introducing auto transformer in between? I'll tell you why we are using this auto transformer. You can also connect without this auto transformer directly to the load, but the problem is if we give full 230 volt to the load may sometime leads to take larger current. So we all know that whenever in a system if you suddenly apply electrical supply, it will initially take always 120% of its normal current, or in other words I would say rated current. So that is why in some of the time when you are suddenly switching on your charger point, when you are putting your plug into a charger point and we are switching on, you can see this spark. The spark is mainly due to the excess current. Okay, that is the 125% of rated current, and it is not going to be there for a longer time. It is going to be only there for a shorter time. But anyhow, if you give full 230 volt to this load, there may be a chance of this load getting heated, and when we keep on switching on and off, maybe the loads will fail also. So to protect this load, I am using this auto transformer. So here this auto transformer acts like a voltage regulator. It is like we are using fan regulator for adjusting the speed. The same way this will work. So using this auto transformer, I can adjust the voltage, which in sense, see, we are giving 230 volt to the system, right? This 230 volt we are getting from power generating station, so we cannot control this. So whatever they are giving, that I should use to the system. Now if I give this 230 straight away the load, as I indicated before, there may be a chance of the load getting heat up because of the high current initially going to flow. So to avoid, I am using this voltage regulator. Using this, I am having option to control what is output I should take. So you can adjust and accordingly you can get the voltage. In sense, if you want to give only 10 volt, you can do it. If you want to give 20 volt, you can do it. So you can slowly adjust the voltage, which means you can slowly give the input voltage to the system, so that your load will not take larger amount of current and it won't get any failure. So that is why we are using this auto transformer. So I would say in single line, the auto transformer here acts like a productive device for your loads. Okay, and then we are having a switch. This is DPSTS switch, which is double pole single throw switch, and then we have an input supply. Now using this circuit, we are going to make a experiment. Now next we will see how can we build the circuit using a practical component. Good morning students. In this video we are going to see how to measure power in power factor in series RLC circuit. So for doing this experiment, this is what the circuit we are going to build, and for performing this experiment we are going to use auto transformer and then voltmeter, ammeter, wattmeter, and then RLC load. So all these loads are connected in series. Now let's see how to make this circuit in a practical way. So you can see the components we are keeping here. So this is what auto transformer, and then voltmeter, ammeter, wattmeter. Then for loads, so we are having resistive load, and then inductive load, and then we are also having capacitive load. Right? Now let's see how can we make practical connection. So initially you see in auto transformer has to be connected to the supply. The input of auto transformer has to be connected to the supply side. So what I do, I will connect the auto transformer input directly to the supply. And then in auto transformer there are two terminals, phase and neutral. So I will name this is phase terminal, this is neutral terminal. So you can look here. Now I need to connect phase of auto transformer to the voltmeter terminal. So I will connect now phase of auto transformer to voltmeter common terminal first. So phase means we all know that it will be in red color. So I am connecting this phase to voltmeter common. You see, voltmeter common we are connecting, phase to voltmeter common. And then auto transformer neutral, I am connecting voltmeter 300 volt terminal. Why? Because we are supplying single phase. Single phase means 230 volt. So for that I am choosing 300 volt range in my voltmeter. So now I am connecting auto transformer neutral to the voltmeter 300 volt terminal. You can see voltmeter 300 volt terminal. Okay. Now we will connect next component. So we will connect now voltmeter common to ammeter. So voltmeter common, I am going to connect now ammeter common. So you see here, this is what voltmeter common, which we already connected to auto transformer phase terminal. So that voltmeter common I am connecting to ammeter common, right? And then ammeter range. So I am going to pick ammeter range of 10 ampere. So now I should connect ammeter 10 ampere terminal to wattmeter M. So I will connect now ammeter 10 ampere, this yellow color wire, ammeter 10 ampere to the wattmeter M terminal. You can see here wattmeter M terminal, right? And then I should connect now M with the wattmeter V terminal, right? I should connect now M and V terminal. So you see I am going to use wattmeter which is going to measure power consumed in single phase load. So I choose voltmeter voltage range for this wattmeter as 300 volt. So I am picking 300 volt. The 300 volt I am connecting to wattmeter M. So M and V I am connecting using a wire. So this blue color wire connects M and V. right? And then this ML and VC is there in internal, so there is no need of connecting this two. So let's move on to the other side now. Now I am going to connect the wattmeter L to resistive load, okay, the phase of resistive load. So let's connect L, this yellow color wire. I am connecting this L to resistive load phase. You can see red color, I am connecting to phase. Then resistive load neutral, I am connecting to inductive load phase. You see, it is actually a 3-phase inductive load, but I am using one phase. You can see there are 3 phases, R, Y and B. I am using Y phase. You can use any one of this. So I am connecting this to Y phase. So this I am assuming as a phase terminal now. Now from inductive load neutral, so these are all neutral point, these 3 are neutral points. What I did is I shorted all neutral because I am going to take from any one of this. So I can take from any one of these 3 as a neutral. So from this inductive load neutral, I will connect to capacitive load phase. You see, I am connecting this to capacitive load phase. Okay, let us come to the circuit diagram now. What we did is we connected resistive load neutral to inductive load phase, then inductive load neutral to capacitive load phase, and then capacitive load neutral. Now you see it should be connected to the common of wattmeter, the common terminal of wattmeter. So I am going to connect this to common terminal of wattmeter. So let's come to the capacitive load. So we are picking now capacitive load common to the wattmeter C. You can see we are connecting this blue color wire, which is connected to the wattmeter C terminal. Okay, right? Now we see which we are connected to C. Now again you see this C has to be connected to either voltmeter 300 volt terminal or auto transformer neutral terminal. So what I do, I will connect this wattmeter common to the voltmeter 300 terminal. So this red color wire from wattmeter common I am connecting to voltmeter 300 volt terminal, right? So this is what the connection. Now we will see how can we perform the experiment. So before you switch on, ensure that your auto transformer in 0 position, and also your all the loads are in off condition. Resistive and inductive and capacitive loads all are in off condition. Right, now we will switch on. So now I need to give 230 volt to the system. So using auto transformer, you slowly give 230 volt to the system. So actually in this voltmeter we are connected under 300 volt. So what are the reading we are seeing over here? We need to multiply by 2. So for setting 230, I need to keep in 115 volt. So let's increase and give the input voltage of 230. So which is 115 into 2. So we given 230 volt to the RLC load now. Now I am not turned on any load. You can see clearly the current is 0 and also power is 0. Now what we do, we switch on the loads randomly, resistive, inductive and capacitive load, and then we will measure the voltage, current and power. So let's switch on the some of the loads. I will switch on first resistive load. So here is a main button. So first I need to switch on the main button, and followed by I switch on 2 of the resistive load. And then I am adding now inductive load. See, inductive load, it is nothing but it is just a coil of wires, right? So when I tight this, it increases the number of turns. Accordingly, it improves the inductance. Right? And then I turn on some of the capacitive load. Right? So now I turned on all the 3 loads. I turned on few resistive load, and I have given some inductive load, and then I turned on few capacitive load. Now let's measure all the parameters. First time measure the voltage. So you can see voltage almost same, right? 230 volt. So what I should do is I record the voltage now. Actually we are seeing over here is a 115 which needs to be multiplied by 2 because we took from 300 volt range. Then I'll measure current. You see current is about 3 ampere. So we are connected to 10 ampere range, so I can take as it is. So current is 3 ampere. Then I'll record the power. You can see power is about this is 100. Each division is actually 10. So 50, 100, 110, 120 watts. Around 120 watts power is taking by RLC load now. So let's record that power as 120 watts. Actually this power is absorbed power, and we need to get actual power by multiplying this absorbed into multiplication factor, so which is specifically we use for wattmeter. So let's see how to identify multiplication factor for the wattmeter. So that needs to be decided based on the voltage and current rating of wattmeter. So we already know that in this voltmeter we took 300 volt, right? So we use 300 volt range. So voltage is now 300 volt. Now to see what is the current rating, you need to see this terminal, how the B1, B2 and E2, E1 are connected. So look at here we are connected B1 and E2, right? And then B2 and E1 are connected. So this will give you the current rating of wattmeter. Now just to check that, you need to see the wattmeter downside. You can see over here, if B1, E2 and B2, E1 is connected, then current rating is 10 ampere. So that is what our case. And for our case the voltage is 300 volt. So for 300 volt, 10 ampere rating, the multiplication factor is 4. So now you should multiply whatever the wattmeter reading you observed into 4. So multiplication factor is 4. So you need to multiply that 120 into 4. That should be recorded here. So this is what now the actual real power consumed in RLC load. Okay. And after that you should do the calculation for the power factor. So we know that power factor is nothing but we can use to get the power factor using the data we have recorded. And we all know that power factor is nothing but VI, that is cos pi, and actual real power formula we know that it is VI cos pi. So this is actually a real power, which was we already measured over here using wattmeter. Now from this I can say now cos pi equal to real power, which we already measured, divided by VI, which is nothing but apparent power. So VI is apparent power. So using a form of real power by apparent power, I can find out the power factor. So real power, you can use the actual data you took from the wattmeter. For apparent power, you just multiply the reading we measured from voltmeter and ammeter. So let's say for this case, now 120 into 2, 48, so 480 watts divided by 120 into 4, correct me, 480 divided by voltage into current. So it is 230 into 3. So you solve, you'll get a power factor for this. See, now we are getting power factor of 0.69, right? So the same you can repeat for different loads. You can repeat the same thing by turn on few other loads, and you can record voltage reading, current reading, power reading, and you can calculate the power factor. Okay, thank you.